The connective symbols used in propositional logic. There are 5 here. You use not. The first one is not. This is to represent negation, and this is the symbol used for not. And you have and to represent conjunction. The third one is or. This one to represent disjunction. And you have conditional. This one you use a single arrow pointing to a single direction, and you have biconditional. This one you have arrow pointing to both left and right direction. So you can use this connective symbol to combine sentence. Okay, example of propositional logic. Elementary proposition, just like in the previous slide. If you just want to represent a simple sentence, then you can use a single letter. For example, it is humid, you can use P. It is humid, you can use Q. It is raining, you can use R. So you can use this single letter to represent a simple elementary proposition. Okay, next you can combine several proposition using connective. For example, here you combine 3 proposition using Boolean operator and also imply, and then you use bracket. This one to represent this long statement. If it is hot and humid, this one is represented in a bracket, and then it is raining. So it is raining is the third proposition, and then you use then to connect the 3 statement here. So then is represented using imply here. The second one, you have 2 statement here, 2 proposition Q and P, and then you combine these 2 using imply here. So if it is humid, then it is hot. So then here is represented using imply. And the last one, the third one, you have two proposition. R you use to represent it is raining, but since it is not, then you use the negation here, and you have it is hot, then you have imply then, and it is hot is the P, the first proposition. So as you can see here, you can use connective to combine more than one proposition. As you can see in the last slide, you can use bracket, and bracket will affect the meaning of the whole PL. So the placement of bracket is very important. Okay, this is another example of propositional logic. Let's say you have the sentence, this one. How to represent this or convert this into propositional logic. So how many statements do you have here? So we have 3 statements. The sky is blue, the sky is windy, and you have this, it is really great for picnic. So you have 3 statements here. You can represent the 3 propositional logic using this variable sky blue, the first variable or the first proposition. and then you have windy, and the last one you have great for picnic. And all these three is connected using the conjunction and the imply operator. And the next example, this one is longer statement. You have how many here? You have 4 statements here. You have the weather is cloudy, and it will be raining. It is raining. You have 3, raining, because this one refer to the same thing here, raining, and the last one you have people will stay at home. Okay? So you have 3 proposition here, and then you can combine these 3 proposition using the connective imply conjunction and also the second one you also have the second imply, and then you use bracket here so that this proposition will reflect the true meaning of the statement, sentence. And then you have the last one, I will stay if and only if it is raining. So you have two proposition here. This is the first proposition, and the second proposition is it is raining, and you have the connective here, if and only if. Of course you can use this symbol to represent this connective. You can also use truth table to determine the truth of the propositional logic. So we have these 3 concepts. That the first one is tautology. This one is true when you call it tautology when sentence that is true under all interpretation. For example, this statement is known as tautology because under all interpretation it will become true. And then the second concept is what we call contingent. When the sentence is sometimes true, sometimes false. This one. Inconsistent, this one is when it is always false. P and not P becomes is always false under all circumstances, so you call it inconsistent. So you have tautology and you have the opposite of that, which is inconsistent, and you also have this contingent, when sometimes it becomes true, sometimes it becomes false. What is truth table? This is an example of truth table. Let's say you have 2 propositions P and Q. So when you want to combine these 2, there are 4 possibilities. Either both P and Q are true, either one is true, which is either P true and Q false, or P false and Q true, or the last configuration is both P and Q false. So not P is the opposite of P. So when P is true, negation of P is false. When P is true, false, the negation of P is true. P and Q, as you can see here, P and Q is always false except when both P and Q is true. While P or Q is the opposite. It is always true except when both P and Q is false. P imply Q, it is always true except when P is initially true and later become false. while P, if and only if Q, this is bidirectional, it is true when both are true or false. When both are equal, true or false, and it become true. When either one is true and the other one is false, then it becomes false. Okay, although propositional logic are very useful in representing a simple idea, it also has limitation. One of the limitation is you cannot use it to express universality of object. For example, you want to express statement all computer have processor, all birds fly. You cannot use propositional logic. Propositional logic is not capable of representing this type of knowledge. For example, all birds fly. If you try all birds fly, you try propositional logic, you have to list out all type of birds. For example, parrot, canary, backyard bird, and so on. So it becomes infinite. So it is impossible to use propositional logic if you have expression like this. The second limitation, if you want to express existent, inexistent, or partial quantity object. For example, as you have this statement, some UMS students are international students. The word some here cannot be expressed using propositional logic. In the first limitation, the word all. In the second limitation, the word some. So, or even none. None of us is immortal. So this kind of knowledge or statement cannot be represented by propositional logic.